Hi and welcome to Algebra. This is a YouTube channel where I present lessons in Algebra 1 and Algebra 2, and today's lesson is an Algebra 1 lesson on quadratic functions and parabolas and all the different aspects of quadratic functions. So behind me I have some important information that you should already know regarding quadratic functions. So let's begin. So a quadratic function takes two forms. It takes the standard form and the vertex form. So let's just try to concentrate on this side of the board. Standard form of parabola has a parent function, y equals x squared. Remember, f of x just means y. So x squared is the parent function. For this parabola, every parabola is based off. So the vertex is at 0, 0, and it's an upward facing parabola without a stretch or a compression because there's no coefficient except 1 in front of it. The only coefficient that you cannot have in front of an x squared variable is 0, because if you had 0 in front of x squared, it would make the term 0, and then you wouldn't have a quadratic anymore. So a quadratic function is of this form, standard form, ax squared plus bx plus c. Okay, and in that form, a, b, and c are all numerical coefficients. C is the constant term, ax squared is the quadratic term, bx is the linear term, and c is the constant. In this form, you can factor it into two factors, two binomial factors, and you can find the zeros of the function that way. If you didn't have the constant term, if that were missing, you would factor out a GCF. You would factor out the x, or if a and b had a common factor, you would factor that out as well, and you could still solve for the zeros of the function. Other things we can do with this form is we have this little formula for the axis of symmetry. X equals negative b over 2a. You would take the coefficients a and b here, plug them in here, and negate the b. So if b is negative already, it's going to be positive here. If it's positive here, it's going to be negative here. Divide by 2a, and that gives you the axis of symmetry. The axis of symmetry is the vertical line that divides the parabola into two equal parts. It also is the only line that will go through the vertex of the function. So the x, whatever the axis of symmetry x is the x of the vertex as well. So this x is the same as this one here. And when you plug it back into the function, whatever that value is, you plug it back in for x, you'll find the y coordinate of the vertex. So this y coordinate is the y coordinate that's right here. Okay. So these are all the different things you could do with your standard form of a quadratic. In the next unit, we'll be going into the quadratic formula, where we can also solve for the zeros of the function when the zeros are, when the quadratic is unable to be factored. So other things that you could do to solve for the zeros when you don't have a factorable trinomial, that will be coming soon. Okay, now on the right here, we have the vertex form of a quadratic function. And the vertex form is f of x equals a times x minus h quantity squared plus k. The vertex is hk, so that's a coordinate point. The h represents the horizontal shift from x equals 0, the parent function. And the k is representing the vertical shift from y equals 0. Okay, so a here and a here both change the shape of the parabola in terms of whether or not it's stretched or compressed or flipped upside down. So if a is positive, you have an upward facing concave up parabola and you have a vertex that's a minimum. If a is negative, you have a concave down, you have a frown, it's negative. Negative parabola is a frown with a maximum vertex. If you have an a bigger than 0, it's stretched like a rubber band. It's stretched by whatever that factor is. And if you have an a between 0 and 1, you have a fractional a. That means it's compressed, so it opens wider. Okay. All right, so we're going to work on some problems today, various problems that are regents, past regents problems, taken from the website jmat.org. It's a great website to visit in order to find a bank of all the Regents exam questions that have been asked since the Common Core Regents began, and even before then. So I pulled a few that I thought we should do today. So one of them is a multiple choice problem, and it gives you a function, and it asks for the minimum value when it wants the value of x at the minimum. Now, gives you a function f of x equals x minus 2 quantity squared plus 4. And it asks for the minimum value. So as soon as it says min or max, think vertex. That's vertex. It's a vertex problem. In vertex form, it should be relatively easy to do. We pull the vertex out. The vertex is equal to hk. Minus h means that the h value is a positive. So remember, inside the parentheses, we switch that sign. So if it's a minus 2, think positive 2. If it's a plus 2, think negative 2. And the k is exactly the sign it is, which is a positive 4. So if the vertex is at 2, 4, and it's upward facing, because I don't have any negative out here, then the minimum value I should have put that down lower. Or I could just do this, I suppose. So 2, 4 is approximately like here, and it faces upward like that. Just a little sketch to kind of help us picture it. And so the minimum value is this point, 2, 4. Now, you have to be careful about how the problem is asked. If it asks for the minimum value, the min value is 4, and it occurs when x equals 2. And that's how it's stated. So this particular problem asks, the minimum value occurs when x is 2, is how it's answered. Okay? All right, next problem gives you an equation in standard form and wants us to convert it to vertex form to answer a question about the vertex form. So we're going to practice changing forms. Now, I have taught a song that goes with this. So the first thing you're going to do is you're converting it to vertex form. So I'm just going to pull it away from my f of x, and I'm going to put my equal sign there, leave a space here, and leave a space here. And the first thing we're going to do is move the constant. Move that constant. So moving it to the other side of an equation means if it's plus here, it becomes minus there. Move that constant. Now, where do I look next? Middle coefficient. The middle linear coefficient is a negative 12. You half it. You half it. That's a negative 6. Then you square it. And that's 36. And you add that to both sides. So I'm going to add it here, and I'm going to add it here. Okay, so move that constant, middle coefficient, half it, square it, add it to both sides. That's my little limerick to go with that. Okay, now, so after you moved it, right, or after I've done that and I know what I'm adding to both sides, what I've created here is something called a perfect square trinomial. And a perfect square trinomial, you know what a square is, right? A square has equal sides. Perfect square trinomial. If I represent this as a binomial times a binomial, the area would that be this. So I'm going to rewrite this as a binomial squared. So it's like factoring it, except instead of writing 2 sets of parentheses with the binomial times a binomial, it's the same binomial because it's a perfect square. So the half number, the negative 6, is what goes inside the parentheses. And then you clean that side up and you move it back again. X minus 6 quantity squared minus 29 equals, I'll put the f of x back in there, and now you're done. Okay, some people have shown this where they don't move the constant term and they leave it here, and they just kind of stretch it out. I like moving it and then bringing it back again because I just feel like it kind of organizes it a little bit better to look at it visually. Okay, so again, move the constant, middle coefficient, half it, square it, add it to both sides. All right, so we've done it, and now I've got it in vertex form. Our vertex is H, switch sign, don't switch sign, Okay, and now we go and see what the question asks. So the question says, if we write it in a general form, x minus a, quantity squared plus b, what's the value of a? The value of a would be the 6, and that is how that question is answered. So it would be a equals 6 for that one, or I usually call it h equals 6. Okay, next problem, we're going to determine the vertex of a function given the standard form. Okay, so I'm going to do another completing the square. To do that, we have a standard form x squared minus 2x minus 8. And I want to determine and state the vertex of the function. Now, this particular problem asks specifically for use the method of completing the square. If it didn't, and it just wanted it algebraically, you could use the x equals negative b over 2h. That's the axis of symmetry, which is the x coordinate of the vertex. After you find it, you plug it back in and you find the y coordinate of the vertex. I'm going to do it both ways just so you can see that you can do it both ways. So a is the coefficient 1, b is negative 2, a negative 2 becomes positive 2, x equals 2 over 2 times 1, so x equals 1. Then you take 1 and plug it in and find the function at 1, which is 1 squared minus 2 times 1 minus 8, which is 1 minus 2 minus 8. Now make sure you work left to right. So 1 minus 2 is negative 1, minus 8 is negative 9. So my coordinate is 1, negative 9. Okay, that means those numbers should appear in my vertex form when I complete the square. So now I'm going to just get myself set to complete the square. First step, move that constant middle coefficient, half it, square it, and add that to both sides. Plus 1, plus 1. So b divided by 2, then squared, gets added to both sides. And then I rewrite it, x minus my half number 1, my b over 2, quantity squared equals 9, bring it back, x minus 2, quantity squared minus 9 equals f of x, hk, 1, change the sign, keep the sign, negative 9. And that is exactly what I got over there. Okay, so algebraic methods, 2 different algebraic methods, one by completing the square and one using the formula for the axis of symmetry first. Okay, next problem has a table involved. Sometimes we're given table values, we're not given a function at all, but we're asked to different questions based on the table. So I'm going to quickly recreate this table. The story is it's a rocket and a rocket is taking off. And we're going to answer questions based on the data in the table. Okay, so we have a time and a height. And as you know, when you're doing these graphs, we don't need the negative x-axis because if it's time, we can't have negative time. So in this one, the time is in seconds and the height is in feet. And it's important to note that because if you're asked questions, you have to answer with the units, with the proper units. Okay, so our first is 0, 180. Then it goes 1, 260, 2, 308, 3, 324, 4, 308, 5, 260, 6, 180, and last one, 7, which is that box, 7, 68. Okay, so based on the data, it wants which statement is not a valid conclusion, and it gives you 4 statements. But before we do this, I am going to suggest that you analyze the table and pull out some important key points to this table. Okay, first of all, 0, 180, this is a starting time. Before it started, the height of the rocket was 180 feet. Okay, so this is a initial. At the start, the rocket was 180 feet up in the air. So it started up at 180 feet. Next thing you should do is look for the symmetry in the table. So the symmetry appears in the y's, because remember in a parabola, the vertex is the only point that does not have a matching y coordinate. All of the other points have different x's for the same y. So there's coordinating, remember the symmetry. The symmetry of the parabola is such that the y's will be repeated, okay, for different x values. And that's okay, because that's still a function, because it passes the vertical line test. The symmetry is where the y's are equal. So I usually like to look at where the symmetry exists. The symmetry is on either side of this value. So this value, therefore, is my vertex. This is the height. After 3 seconds, so at 3 seconds, it reaches a max height. And the max height it reaches is 324 feet. Okay, so that's important information. What else? What do I notice? It doesn't hit 0 feet. So according to my table, it hasn't landed yet. So even after 7 seconds, it's still in the air. And that could be important. If I had a 0 along the table for the height, that would indicate that it landed. Or if it went negative, that would indicate that, sorry for that pause for a second. If it went negative, that would indicate that between 2 seconds it landed somewhere, but it's not, so we're good. All right, so that's all the information that I'm going to have. Now I'm going to read the choices. So the first choice, we want the one that's not valid. The rocket was launched from a height of 180 feet. True or false? Yes, true, right? Height, 180 feet. It was launched, initial, start, 180 feet. That's good. Choice 2. The maximum height of the rocket occurred after 3 seconds. 3 seconds after the launch. Max height would be, oh yeah, at 3 seconds. So that's true as well. Choice 3. The rocket was in the air approximately 6 seconds before hitting the ground. Ooh, it's not on the ground yet. And that's at 7 seconds. So no, that is false. And that's our choice, because that's the one we're looking for, the not a valid conclusion. But I'm going to read the fourth one. The rocket was above 300 feet for approximately 2 seconds. It was above 300 feet in this window. From 2 to 4 seconds is, yes, approximately 2 seconds. That is correct. It was above 300 feet, okay? And that's how you answer a question such as that. Okay, last one I'm going to do has to do with if you're given the zeros of a function. Okay. So in the next problem, the problem gives the zeros of the quadratic function. So it says that if the zeros of a quadratic function are -3 and 5, it wants to know then the equation of the axis of symmetry and justify your answer. So justify means show the math that leads to the answer. And explain means write the words. So we need to justify our answer. So we have to show some math behind this. Okay. So let's just conceptualize what's happening here. The zeros of the function and where the parabola crosses the x-axis. So this is crossing the x-axis at -3 and at 1, 2, 3, 4, 5 here. Now, these have the same y coordinate of 0. So directly between them is the axis of symmetry. So between -3 and 5, if I take -3 and I subtract 5, right? Take the difference, I get a -8. There's 8 units between them, right? Take the absolute value of that because we're talking about distance. 8 units, cut it in half. 4 units from any one side gives me the axis of symmetry. So I could take -3 and add 4 to get 1, or I could take 5 and subtract 4 to also get 1. So at x equals 1, I have my axis of symmetry, okay? It's the distance between them cut in half. So all of this you could show just by, you could count 1, 2, 3, 4, 5, 6, 7, 8 units. Half of 8 units is 4 units. 1, 2, 3, 4. 1, 2, 3, 4. X equals 1 is it. Now let's turn these into factors and also do it by the equation, okay? So an equation of this could be this factor -3 is written as x plus 3, and the factor representing the 5 is x minus 5. So remember, if these are your x values, these are your x equals -3 and x equals 5. Where did they come from? They come from, let me just move that over. They come from when you have a factored trinomial and you set each factor equal to 0 and solve for them. So we're kind of working it backwards. So the 0, -3, the factor is x plus 3. The 0, +5, the factor is x minus 5. Just remember, it changes signs. Now if I use my double distributive method or box or FOIL, you take your first times your first minus your 5x, I'm double distributing, plus 3x, minus 15. Then I'm going to clean that function out, adding those middle two like terms. And now that is my function, y equals x squared minus 3x minus 15. X equals negative b over 2a. X equals -3. What did I do here? That's a 2, sorry. Oops. 2, -2, and I noticed that as soon as I looked at what that was going to end up being. So 2 times 1 is x equals 1, and it confirms what I found over here. Which, good thing I found it, because it's easy to make little silly errors when you're going quickly and not thinking. So -5 and 3 was -2. Now if I had made that mistake and followed through with it, I might have answered x equals 3/2, and that would be incorrect. And I would, had I done this originally by plotting and finding it, then I would have known what I'm expected to get. So it's always good to know, what should I be getting for this? I should be getting x equals 1. So I noticed, oh yeah, okay, I made a quick adjustment and x equals 1 is the correct answer. Okay, so that is my review for today. Look forward for more videos on some review for quadratics and parabola. Probably another one coming tomorrow, and then we'll be getting into, in later videos, the quadratic function and what happens when you have irrational roots and roots that don't actually cross the x-axis. We'll be looking for that as well. Okay, stay tuned and hope to see you soon. Take care. Bye.